All right, welcome to this example here where we're going to take a look at an isosceles triangle and try to determine what the altitude or the height is of our right-angled, of our isosceles triangle. Now, the first thing that we need to do is we have to draw out an isosceles triangle. Isosceles triangle looks something like this. Okay, it means that the two sides of the triangle are the same height, and they also actually have the same angle in the corners. So that's something we know about this triangle. And then the base or the bottom could be whatever length it happens to be. We're told in this case that the length is 16 centimeters long. And then we are asked, what is the altitude or the height of this triangle? All right. Now, how do we solve for this? Well, first thing, we need to know what that slant height of our triangle is. We need to use that. We're not given any angles in this case, but we are told that the perimeter is 60 centimeters. So let's take a look at how we can find the missing side lengths. Well, as is an isosceles triangle, like I mentioned, the two sides are the same length. Okay, we know that the full perimeter is 60 centimeters. So if we take the full perimeter and subtract the 16, that's the base that we already know, we know that the two sides of the triangle are going to add up, to 44 centimeters. Well, two sides, the exact same length, we can divide it by 2, and we know that each side has to be 22 centimeters. So let's plug those in. All right, now we have a bit of a better idea of what our isosceles triangle looks like. Okay, next step. We want to try to figure out what is the altitude or the height of our isosceles triangle. And so to do that, we're going to make this into a right angle triangle, which only deals with half. And so if we have half, we're given the hypotenuse of 22. That base there has to be half of the 16, so we're going to plug in 8. And now we can use Pythagorean theorem in order to come up with the height of our isosceles triangle. Now you'll notice I've already mixed Pythagorean theorem around a little bit. Because we're given the hypotenuse and one leg, I'm going to do c squared minus a squared. So we're subtracting those two. We plug them in, 22 centimeters and 8 are going to be the hypotenuse and the one leg. B is going to be our other leg, which happens to be the height. Do the calculations. 484 minus 64 gives us 420 square centimeters. Yes, that's a notation thing. Don't worry too much about that. We take the square root of both sides. That way we get our b all by itself, not b squared. And we're going to get that b is equal to 20.49 centimeters. There we go, and we plug it in. That is how we can figure out what is the altitude of the triangle. And it's using right angle triangles and some properties of triangles as well in order to come up with the answer. Thank you for watching. I hope this has helped you and it's given you some insight on triangles.